Hello everyone and welcome to lecture number 4. In the last lecture we have seen Weiss molecular field theory. For the relation between chi, we have seen Weiss molecular field theory for the relation of chi and Tc, right? For the relation of chi and Tc, we have obtained the relation between chi and Tc, that is chi is equals to C by T minus Tc. So, how the magnetic susceptibility changes with respect to temperature of a material, that we have already studied, and we have seen some graph in that theory. Now, going ahead, we will study the reason for Weiss field or exchange field or molecular field. We will study the reason or the origin of the Weiss field or molecular field or exchange field, right? We will study the reason for it, and in that we will include the topic is including the Heisenberg principle also, but going for to understand the Weiss field, the origin or the existence of Weiss field or molecular field or exchange field, before that we will see two small topics, that is a two-electron system, singlet and triplet states. Two-electron system, singlets and triplet states, right? Now, today we will see two-electron system having singlet and triplet states, right? Singlet and triplet states. Now, we know that if we have a single electron, let us say electron 1, if we have a single electron, let us say electron 1, then this electron can rotate on its axis either in this direction or either in this direction, right? It can rotate clockwise or anti-clockwise. Okay, now what will be the spin value? The spin values are fixed. We have already studied, that is plus half and minus half. Now, if this is rotating in this direction, then we can have three axes, that is x, y, and this is z. So the spin or the z component, will be plus 1 by 2, right? Will be plus 1 by 2. And if it is rotating in this direction, then it will have minus g. It will have a spin in the opposite direction, that is minus z, right? So that is minus 1 by 2. This is the z component or spin. This is the z component or its spin, right? We have studied that spin of an electron can be either plus 1 by 2 or minus 1 by 2, plus half or minus half, right? But this is for the case of a single electron. So it will have a single energy level. It will have a single energy level. It will have a single energy level, a single state, right? But if we assume or if we take the case of two electron system, then what can be the possibilities of its spin? What can be the possibilities of its total spin? And z component. What will be the possibilities of the energy states? Its total spin and z component. That is, we will study in singlet and triplets. Now let us assume that we have two electrons. Let us say electron 1 and electron 2. We have two electrons. Let us say electron 1 and electron 2, right? We have electron 1 and electron 2, right? Now suppose the electron can have either up spin or down spin. Up spin will be in this, down spin will be in this direction, right? That is plus 1 by 2, minus 1 by 2. Okay, this is plus spin and minus spin, plus half, minus half. Okay, now what happens if we have the addition of two electrons? What happens if we have an addition of two electrons? Remember one thing, that both the electrons are identical. Both the electrons are identical. Right? Then electron can have plus spin or minus spin, plus 1 by 2 or minus 1 by 2, right? Then if we adding the spins of two electrons, we can have case 1, that is, this will have positive, this will have positive, then the total will be positive, right? And it will give us plus 1. It will give plus 1. This is nothing but z component. And total spin will also be 1. Remember, this z component is nothing but magnetic quantum number. So magnetic quantum numbers can have plus or minus values. This z component is nothing but the magnetic quantum number. Magnetic quantum number, which is we have studied as m, and that can have positive and negative values, while the total spin will be 1 of a 2 electron system, right? The another case will be the down spin. It will have down, this will also have down. So the total will be given by, this is also down, this is also down. Minus 1 by 2 is equals to minus of 1. And the total spin will be 1. Total spin will be 1, right? We will have z component in the negative z direction. We will have z component in the negative z direction. That is why it is -1, right? Now, these are the possibilities when we add the spin of 2 electrons. But other than this, we also have some possibilities where this can be up, this can be down, this can be down, this can be up, right? Remember this red one, 3 and 4 number. One is up, one is down, one is down, one is up, right? This is the complicated part. This is the complicated part. Over here, we will get is equals to 0. Is equals to 0. But remember, these states are not allowed. These two possibilities are not allowed. Why? Because both the electrons are identical and we have no idea about the electron, which is electron 1, which is electron 2. Now, how this came? Remember the Heisenberg uncertainty principle. If you have a set of 2 electrons, you cannot predict that either of the electron will be electron 1 or electron 2. Right? This can be electron 2, this can be electron 1, this can be electron 1, this can be electron 2. Again, it can interchange according to Heisenberg uncertainty principle. You cannot predict the particle, you cannot have a specific particle identification. According to Heisenberg uncertainty principle, you cannot have a specific orientation of a particle. That is, you cannot say that this is electron 2 or electron 1. You cannot say electron 1 or electron 2. That is why these states which are in anti-parallel are being not allowed. These states are being not allowed. Right? Due to uncertainty principle. Remember, due to uncertainty principle. Right? So if this is not allowed, then there has to be the combination of these two states. There has to be the combination of these two states, right? Now, the combination of these two states will be given by you can write as the total summation will be equals to plus, and for the fourth state this is nothing but the combination of states. Over here we will get z component 0. So this will be equals to 0. This will also be equals to 0. Z component will be 0. Right? But we have a total spin of 1, total spin of 0. Now this is the term, or this is the point at which the number of things are getting confused. So these two states, so this state is clear to us. This state is also clear to us, but let us see the third and fourth in detail, because these are confusing states. Let us see third and fourth in detail. So the state 1 and 2 are clear. We have z component plus 1 and total spin 1. For the second state we have -1 and z total spin as 1. Right? Now let us see this 3, 4 in detail. This in detail, right? Now, so the possibility is either I have equals to 0, z component total spin, the total spin will be 1. Total spin will be 1. In the another case, this will be 0, total spin will also be 0. So from where do this states, this z component value and total spin value is coming? From where do this is coming? Now let us take an example. Let us take an example where both the electrons are having same spin. Both the electrons are having same spin, right? In that case, the vector addition will be something like this. The vector addition will be something like this. So the resultant vector is in z direction. The resultant vector is in z direction. The resultant vector is in z direction. That is why we are getting total spin 1 for both parallel. So total spin S is equals to 1. Now for the second case, if both are in the same direction but in downward direction, then what is going to happen is over here also S will be equals to 1. Over here also S will be equals to 1 because we have a particular direction, because we have a total spin, because we have a resultant spin, right? These are the vector addition of two. Let us say this is for the first one is this and the second one is this. In the similar way, the first one is this and the second one is this, right? The second one is this. So this is nothing but the vector addition. But these two cases are clear to us. These two cases are very much clear to us. The complication was in the third and fourth stage, the third and fourth case, right? So let us see what happens for the third one. For the third one, that is right. In this case, if we take three axes, then the vector addition of two spins will be in such direction. So the vector addition of spin will be in such direction. Remember, over here we are not getting z component. Z component equals to 0. Z component equals to 0. But the spins are adding in some another direction. As both are adding in another direction, we will have a S. We will have vector S. That is total spin. That is equals to 1. As the resultant vector is not in the Z direction, we have Z component 0. As the resultant vector is not in the Z direction, we have Z component 0. But we have a resultant vector in another direction. Let us say that direction is X, and that is giving the value S is equals to 1. That is giving us the value S is equals to 1, right? That is giving the value S is equals to 1. But let us take the another fourth case. So I think this case, this state is clear now, right? Because the resultant vector, of the addition of two spin states, two spins of an electron is in the non-z direction, we are getting z component 0. Total spin we are getting 1 because it is having a resultant vector in a particular direction, in let us say x direction. That is why we are getting s is equals to 1. Now let us take the fourth one. What happens for the fourth one? That is for the fourth one. The fourth one is, sorry, I kept some mistake over here. For this, let us take an x-axis. Both the spins and the vectors will be in opposite direction. Both the spin vectors will be in opposite direction. So z component are exactly opposite to each other, therefore z equals to, we are not getting any resultant vector in z direction, so the z component is 0, and s is also 0, because these both vectors, are in opposite direction. So each of it will try to nullify it. This will not produce any of the resultant vector and giving us s is equals to 0, because the resultant vector is not forming over here in any of the direction. So the total spin will be 0. For this combination, the total spin will be 0. Now, I think all four we have covered. Now, all four these possibilities, let us combine in a tabular form. Then it will give us four possibilities. That is either both the electrons have positive spin, both the electrons have spin in the same direction, then total spin S will be 1, and the z component is nothing but, remember, is nothing but magnetic quantum number, can have positive or negative value. Z component don't get confused. Some of the textbook may use as z component. Some of the textbook may use as z to represent the z component, but that is one and the same. So don't get confused. So the z component will be +1. Now, for the down spin, we also have total spin 1, and z component will be -1, because the resultant vector will be in the negative z direction. The resultant vector of these two will be in the negative z direction, right? -1. Now, the third possibility is plus, right? This will have total spin 1, but will not have that spin resultant vector in z direction, so the z component will be 0. And the fourth one is over here we will have both z component and total spin will be 0. Both this, in this condition, both are in the opposite direction as we have seen. So over here we have 4 possibilities of spin states. 4 possibilities of spin state. These are known as triplet state. And this is known as, the last one is known as singlet state. The last one is known as singlet state, right? So this is all about a 2 electron system, singlet and triplet states.